Hey, I'm Kotov. Welcome to Material Alphabet and Houdini, a series where I go through the alphabet, creating a different material study for each letter. Each chapter explores a different material and a different way of approaching geometry, texturing, and rendering. In this episode, we're finishing the charcoal chapter, guided by the simple principle: what camera doesn't see is not a problem we need to solve. Let's get started. Let's see what kind of particles we can get. Because we already have drawing charcoal piece, we might as well use it. But we only need the bottom polygon to spawn points. I could use the fancy group by normal thing and blast every polygon that's not facing negative y, but I decided just to do that by hand. That's gonna be a relatively easy particle simulation. But we will need the ground plane. When you're writing stuff after the solver, it's always a good idea to change affector relationship on the merge to mutual. I don't want display in proxy geometry, and I think we already have some velocity attribute on the piece. I could randomize that a bit, but I decided against that. I just want to scale it down slightly. Now particles are flying in all directions and will never stop, because they don't have any force to help them do that. Pop wind node has air resistance. That's exactly what we need. We could also change a few attributes on the ground plane. For example, I don't want any bounce. Pop wind node wasn't enough, so I decided to use pop drag. This node is designed specifically to imitate air resistance. It also would have helped if I didn't forget about gravity. Now all is left to do is to find the right balance between initial velocity, air resistance, and gravity. I notice here that I'm getting steps in the simulation, and raising sub-steps didn't really help. I decided to jitter points before the simulation to fix that. Because we are using ground plane, it's also being exported from the popnet. We have to specify which nodes we want to be exported using this expression. We will do p-scale randomization later. Right now let's create outNull, geocontainer, and assign material to it. Now let's randomize p-scale using attribute randomize node. For some reason disk preview didn't work here. We can also use global scale multiplier to scale our particles. They're supposed to be really subtle. Let's see how everything looks together. There's probably too many of them. Let's cut a few raw points. I will check if it holds up throughout the animation. It's definitely better with them. Let's work on the camera color correction next. Now that that's done, I will add a few more path variations to the setup. Basically, it's gonna be just copying and pasting the setup we already have. Except for the curves, they will be different. To make it easier to animate the point, you can plug it into the setup we have. That way it's gonna be easier to see the animation path, and you can adjust it as you go. If you're gonna be merging two points together, like I do here, you have to make sure each one of them has its own unique ID attribute. As you can see, it looks broken in the viewport, but that's just a visual bug. Now that I have confirmed that it's working as expected, I'm ready to give each curve its own setup. The one thing I'm going to change from setup to setup is going to be sweep thickness. so the paths aren't that uniform, and we have some visual variation. The one problem we will encounter soon is going to be that charcoal pieces aren't uniform with the paths. But for now, I just want to set up thickness for the paths. Had to restart Houdini here. I've decided to animate curves using Carve node, but that caused UVs to shift. I'm checking to see if there is any parameter that I'm forgetting about that might help me with that. I will deal with that in a moment. For now, I want to create one null and call it curve in, just for organization's sake. The easiest solution to that problem is just to freeze curve on the last frame and transfer UVs from it. Attribute copy didn't really work, but attribute transfer will. Now UVs are staying in place. I'm gonna copy that attribute transfer and time shift to every stream I have. On some of the streams, I have UVs created later. We don't need attribute transfer on them. Now I will create some of the curves that I want, and will get back to you once I'm done with them. Now that I have all of the curves, let's do some house cleaning and organize project a bit. That's the animation we have so far. It's a bit too linear for my taste. All of the animations end at the same time and go with the same speed. I will change that with the curves. Let's also check if they're rendering as expected. Not every layer has to cast shadow. I will turn it off for some of them. Now it's much cleaner. I will take a snapshot and continue working on individual lines' thickness. Basically, all the setup we have is those 4 streams. Everything before that is just different curves. To make it easier to manage thickness, I will work on them in groups. I will have a helix group, the word group, and 2 doodle groups. For now, I will focus on helix and the word. Let's get their thickness right first. I've decided that helixes are too perfect for hand drawing. I will use a mountain sop to rough them up a bit. Amplitude in y-axis must be set to 0, so they don't intersect with the canvas. I will do same thing to the word. Now I will dial in the first doodle group. I will offset their animation slightly, so they don't start and end at the same time. Now the timing is closer to what I want. Now that we have all of the 4 groups plugged in, let's see how they're looking together. Well, doodle groups are way too thick. We'll fix that first. Maybe we'll make helixes thicker. And let's scrub through a timeline to make sure animation holds up. Now the next step would be to create the drawing pieces for each of the curves. That's why I was using carve for curve animation. It can output the endpoint for me to copy the piece onto. Project is getting bigger, and it's more difficult to navigate in it. I will use nulls and object merges to make it easier for myself. We already have a setup with trail node and copy to points. I will just make sure that it works and that the scale is correct. To make scale work procedurally, I will use p-scale. But first I will have to make sure that the original piece is not scaled down. Now I will set p-scale value for each of the points. But that way I will still have to set p-scale by hand. Luckily, we already have a scale value in sweep node. If I copy and paste it as a relative reference, the drawing piece and the curve will be the same size. We can check it right here. Now we don't have to worry about the size of the drawing pieces. They will adjust automatically. Now just to apply the same setup to the rest of the groups. I will use nulls and object merges, so that I don't have wires running all across the project. Now all of the drawing pieces are wired to one null. It makes it way easier to manage. Because next we will have to run pop simulation off of them. I will use group node to select all polygons pointing downwards. Next, I will delete everything except for them. And we already have a working simulation. We just have to plug those new polygons into it. I decided to use density scatter instead of fixed point count. For caching, let's delete all unused attributes. I will leave these ones. I will also delete any groups, and finally cache it. Now we have a slight problem. Even though the pieces are staying in place, simulation is still going, and we get condensed areas of particles, like this one. I'm thinking maybe I should raise particles slightly, so they don't intersect with the canvas. But that way their shadow gets messed up. I decided against that. The easiest solution to our particle problem would be just to move their starting point from the screen. We can use soft transform on the edit node, and add resample afterwards. Now all of them start off screen, and we don't have that problem anymore. Now we can cache particles again, and get to rendering charcoal piece itself. Material for it will be pretty straightforward, but first we will need UVs. Basically it's gonna be a dark material with pretty heavy bump and slight roughness. I will also use round corners for this one, because camera doesn't get too close to them. I can get away with just render time bevel. Now we are ready to cache it and send it rendering. That's it for the second episode and the charcoal chapter. If you missed the first one, link to it in the description below. You can also check out the complete Ember and Bubbles chapters. Link to Material Alphabet and Houdini playlist is in the description as well. If you enjoyed this video, leave a like and subscribe to follow the series. Hope this gave you a few useful ideas you can apply to your own work. Thanks for watching, and I'll see you in the next one.